Okay. Here we are back. Streaming again. Okay, so today we're gonna keep working on weapon functions. We're gonna choose some easy ones and see if we can make some more progress. What are we doing here? We are in the process of decompiling Castlevania Symphony of the Night for the PlayStation 1 console. This was originally written in C, compiled to MIPS, and then built for the PlayStation SDK. So what people who are smarter and more diligent than me have done in the past is gone through and figured out what the structure of that CD is. Where the code and objects reside in each of the files on the CD, how to extract those and partition those, and using some other tools created by the decompilation community, have begun trying to reproduce the C code to produce a byte-perfect compiled object using old compilers and other things that we have. So what we're doing now is attempting to find files that haven't been decompiled yet, files that are relatively straightforward and just require the grunt work to go through and decompile them, and doing that. There currently is a status page that shows what has been decompiled. There's one function left in the main game. Every PlayStation file has a SDK and bootstrap file. That's in process, but it's not listed on this page. That one requires a little more work, but it is in process. The Richter program is finished, so this is the Richter character. What we're working on today has to do with weapons, so getting some of those weapons done. There's a lot of weapons. This is just the first weapon file of 2. Center Castle was one of the early finished levels. Nightmare, I believe, has one function left. That's a relatively hairy one. The debug room, it has very similar but slightly different code from all the other levels, which is why it's not done yet, but that's a lot of grunt work. The entrance, the first visit, most of this code, if not all of it, is already decompiled in other stages. Stages share a significant amount of code with each other. The missing piece is mapping where that code, what addresses the code and data live. So once that's done, some of that requires, when things are decompiled, temporary variable names are created based on the address of that particular data, because the decompiler doesn't know what any particular piece of data is for. And so every level is offset slightly with every other one based on the assets that it includes and what functions it includes. So eventually somebody has to go through and figure out what those correct offsets are for NO3. NP3, extremely similar. That one's done. NZ0, done. There's one function left, which I'm in the process of working on. I'm about 99% of the way through, but there's just a few mismatched registers in the code for the selection screen, and on and on. But today we're going to be focusing on weapons, and to decompile weapons, we're going to use a tool called decomp.me. And there's already presets here for decompiling Castlevania Symphony of the Night. They were set up long before I joined the project. So we just need to find some assembly that we're interested in decompiling. So we're going to start off by looking at the files that haven't been decompiled yet. Some of these early weapons I've not done. I've mostly been sticking to some of the later weapons in the 30s. But we can pick this first one. It's possible that somebody else has already started decompiling this, and we can actually search for that and see. So it's possible that somebody has, but there's nothing obvious there. So let's take that one. So we're going to take this assembly file. Excuse the when I switch tabs, you can't see it. So thank you for protecting us, Mac OS. So let's open this here. We'll open it again, get coloring. So this is what the assembly file looks like. One of the first things we look for is if there's a jump table. Jump table means that there is a switch control statement, and there's nothing wrong or bad about having a jump table. It just means we have to treat the code slightly differently. So I'm going to take that code. I'm off in a different terminal at the moment. That makes it easier for me to copy and paste. So I'm going to take that over and paste that into decomp.me, just as it is. For this, since there are no jump tables, I'm not going to change anything. And I'm going to see what the decompiler will produce. And this is actually really close right off the bat. This is relatively surprising to be this close, and nobody had decompiled it previously. So we will do that now. So just as a convenience, we're going to rename this to give it the weapon that we're working on. This is primarily as an aid to other people who might come through and want to decompile this as well. Animation frame. This particular animation frame is going to be an array, so we can get rid of that. Okay, so let me back up a bit and describe what's going on here. So we pasted this assembly that's in the left column here into decomp.me. It did its best effort to decompile this function based on previous information that we had given it. So this is data types and function signatures that we already know are either correct or relatively correct. And it will try to produce C code which matches that assembly. Decompiling is more of an art than a science, so it really gets it perfect. There probably is more work that can be done on things that decompiler could do to automatically permute some options when it's decompiling, but in this case it gets us pretty close. So this, based on this diffing algorithm, it tells us that it's 86% similar to what the original binary was. So our code that we have here, it's producing the binary in this right column, and our goal today is to try to get this code to match exactly what's in the left column. Once it matches exactly, we can replace this assembly in the project with C code, and that C code then can be retargeted to other platforms. So we have the code that we have, but we also have a context. Context is used during the decompilation process. And so sometimes there are these global variables outside the function. Sometimes we want those in the context. Sometimes we want to keep them here because they're kind of, even though they're global, they're private to this function. In this case, the hand ID, that is something that is well defined and used very several other places. We don't need that. We're still getting a few problems. These particular problems are because GCC, which is the compiler that's used to compile the C code, has built-in versions of standard C functions, and it does that so that it can optimize what implementation is used based on the code that it sees. But the PS1 SDK provides those functions and links against them, so we're not going to use those, so we're going to see no built-ins. If we need to override that later, we can, but right now we don't. So other bookkeeping, let me do a quick search for this. So I'm going to look for this particular address and see if it's common to use this. Other places I don't recall offhand. This actually might be the what's considered no, it isn't the animation set. Okay, so typically these are arrays, so we're going to make that array. This is just something we know from experience. So as we're changing things, we want to keep track of this compilation score here. We want to get the number that's starting as low as possible and get the percentage as high as possible. So every change that we make, we're going to be gauging both based on the code that's generated, but also that number to see if we're getting closer. So the player is a macro to the first entity in a set of global entities. But when the assembly is extracted, it doesn't know about the shape of structures. So as a convenience, some of these memory locations are mapped out beforehand. But really, this is going to end up being structure access. So we can change that. And that will change our code slightly, but we know that will be correct once everything's done. So we won't need that variable in the future. And then this other variable, all we know is that it's some type of flag. And that's probably all we'll know for now. The other bookkeeping to do while we're getting ready, we can pull both these out into the context as well. We won't need those to look at those again probably. The other bookkeeping is functions that take entities as their first argument. We treat them kind of like object methods. And so being an object method, normally you would have a this pointer, which points to the object that the method is being called on, or some languages, Python and Objective-C, use the term self. Self is the idiom that's used, or the convention that's used here. So we're going to replace all arg zeros with the variable self.
And self is used partially because there is some work on a PC port that is written in C++ where this is a keyword and can't be shared there. All right, so let's save our work, and then let's get to matching. So what I typically do when matching is go through and just kind of match a lot of the idioms that we've seen already. One of the things I see right away is we have two local variables. Often local variables aren't necessary, or they might be superfluous for some other reason. So let's look at what this temp v0 is being used for. So an entity is being created, so we have an entity factory that is using our current weapon, or our current weapon is being used to create a entity factory. So nothing too exciting is happening there. We're just creating another entity, which is an entity factory. So we'll rename that factory because that's what it is. So as long as if the factory gets created and we're using, basically we're choosing the entity ID that we're creating based on the hand that this current weapon is placed in. This won't change things too much. So when we're editing in this editor, we can see that we're on line 15. We can scroll down to line 15 and see what this looks like. So basically what we're saying is if the if we're using one hand, choose this entity ID, otherwise choose the other entity ID. So we'll rename that entity ID. We might be able to get rid of that variable later altogether. We'll see. Okay. So now let's kind of go back up to the top. So on line 8, on line 8, we get to our first issue. So we're setting flags here, but the original assembly is setting the Z priority. So let's take the Z priority and reorder it, and that cleans up a significant amount of this code near the top. When there's I's in the diff column for the target and our current code, that means the immediate value, or this address, is different between the two. That's going to happen because the assembly was generated with a named symbol, and we're using a calculated offset based on a slightly different symbol name. When those get compiled into machine code, they end up being exactly the same. But unfortunately, the decompiler doesn't know that, and so it's going to flag those as differences. And unfortunately, there's not much we can do about it. So we did make quite a bit of progress, though. So we were at 86%, and now we're at 91%. So we'll save and continue. I know that flags is going to be a set of constants that we already know. So I'm going to go over and start looking those constants up. So it looks like these might be the correct ones. So we have one, two, three, four, three. So this is unknown flag ORed with another unknown flag. Unfortunately, we don't know what all the flags do yet, so that's what it is. So this velocity is another interesting value. Negative hex 10,000 seems like it's a huge number, but it's actually a fixed value, which we don't see in modern programming that uses floats for everything. I have a terminal that has a converter that I wrote earlier today. So we're going to convert that into the fixed representation. I'm doing this off screen because it's more convenient for me. Sorry. So that turns into fix -1. Fix is a macro that will convert this back in the right format, and you see the code doesn't change, generates the same binary. Great. Okay, so we're going to scroll down. Now, here's where we get into an issue. We have registers that are wrong. We don't know why yet, so let's keep moving and we'll see if we can figure it out. First, we're going to change this to struct access from the symbol before. Again, that's going to change the immediate value, but nothing else. It does reduce our score, but it's more correct. So we stick this so we have a value that is being put into the A register, which is a argument register. When we don't expect it to be put into the argument register. Eventually we move it out and it's used elsewhere, but for now it's not where we want it. There's nothing obvious to me here why that might be, but we can look for other code that uses this idiom. And see if there's anything obvious. So we'll try this one. It's just one I chose at random. There's nothing I know about this more than anything else. so we have something relatively similar where we're selecting flags based on the hand. But nothing else really. Yeah, I'm not sure. So we're going to skip this for now and keep going. Sometimes, unfortunately, figuring this out would help us solve something down the way, but right now we don't know what that is. So kind of moving down, I like to take these plus equals 1. Most of the time these are plus pluses. Sometimes that actually clears a lot of things up. Sometimes it doesn't. Another one is these where we're adding something to itself, changing those to plus equals. That actually cleared up quite a bit. So let's go back to what that looked like before. So we have a lot of mess here. One thing I'm going to do, just because I like the way it reads better, I'm going to change this to a -6 on -3. Move these outs. Move these after the function call. That itself clear up a bunch. So we went from 675 to, or from 820 to 675. But then we're going to change this to a plus equals. We're going to change this to a plus equals. One of the reasons we do this is because the compiler is going to infer types for us, and it's going to possibly choose. So there's casting and other things that was being done by the decompiler to try to emulate the instructions, but it chose those poorly. And from seeing other code, we know that that's not the way that this is typically written. So we can save. We're really close. So step, we're going to change that to a plus plus as well. And as I said before, sometimes that helps, sometimes it doesn't. And now looking back at what we have, we are really just looking at this here. So if I was going to write this in modern code, I would use a ternary operator and say that this was BF, otherwise it's FF, and then we don't need this entity ID at all. But that doesn't help. Code is equivalent. So let's go back then and see if we have other cases where we're setting an entity ID based on the hand. So we're going to grep for entity ID equals and what then? And we're going to look for we're setting an entity ID. So apparently we're never setting entity IDs anywhere else. That's interesting. So
sometimes you get into these ruts where the code makes sense as is, but the wrong registers are being chosen, and it's really not obvious why. So we have a couple choices here. Sorry. We can let's first look for cases where, let's see what this factory macro does. So in this case here, to set the flags as the second argument, they're using a factory macro. Let's see what that does. Okay, so we're going to be shifting over one of these by 8. So it's going to be the B0. Sorry, B00. And ORing. So here we can change this. Okay, that gives us the same value, 13, 12. Okay, so let's try this. Let's assume that we are going to set this to this particular value. Otherwise, we're going to set it to the other value. So that's worse. It's okay. The next thing I'm going to try is, originally there was a short that was being used to store this value. Let's just try making this an int. This happens quite a bit as well in this code base. The compiler will do funny things. So that didn't get us any closer. We can try that, or try 8 bits. None of those are working. None of those are being treated any different. sometimes those things work. So, what is next? What I like to do at this point, I'm sorry, once again, I have the wrong window up. I was just poking around with changing how that entity ID is assigned to the factory. Let's actually look at the context. So everything right here is right except for where it started. Let's get rid of that variable again. Let's try this. Let's move this out of here. No different. This is kind of a hack as well. So sometimes that works. It's not glamorous, but sometimes you do what you gotta do. Okay, so none of those things have worked. Let's take our code, put it into the project, and see if it compiles. This is a new branch. Actually, it's not a new branch. I was just decompiling memmove from libc in there. We can reuse this. This should compile cleanly. All right, it does. It looks like something is, one of the dependencies in the make file is broken. All right, let's open this up. Weapon, we are looking at weapon 15. Oh, there's a lot that's not compiled here. And we're looking at this, oh wait. So we're gonna paste our code there. Get rid of the include, and we're gonna see. And so we have things that are not defined, and that's because we had defined them over here. So we'll pull those in. And it fails. And so I have a little script for diffing that. And so this is just the binary of that weapon object that's being created and showing what the difference in that binary object is. There's two lines that are different, which probably correspond relatively closely with these two things. I can, just from experience looking at this, it's more likely than not that this is the same error that we're getting over in decomp.me. So let's go back to decomp.me, and we'll try a few more things before going to the permuter. So one thing I see here is we're setting x after y. That's not common, so we'll switch those. In this case, that was correct. Sometimes it's not. Okay, so what we're doing here is saying if we haven't Basically, we're treating this as a Boolean. So if this bit is not set, so can we just say, do we have to ask? Is it gonna, yes, it wants us to ask. So if that doesn't exist, and what about this? Okay, so that's really happening afterwards. What else? The draw mode, this is going to be a constant as well. We could go back and find and set that, but I'm not too concerned about that at the moment. Let's go back up here and see. So we're using argument 1 instead of V1. V1 V1 is previously being used here. Let's look at what V0 was being used for. V0 was being used for this. So we assume that this was an int. It might not be. Let's pull that back into, we can do a few things. So we're going to go through and see how this looks in memory. So this is going to be so this is defined in the zeroed out section of memory. Let's grab that address again. We see it as just a big blob. So we can go over here and try a few things with it. I don't think any of these are going to make a difference, but we can see. We can try making it a 1 byte size, short. That makes a difference. Let's try making it unsigned. Also does not make a difference. Okay. So another option is maybe it is an array. And so we are going to be looking at dereferencing it to do any of the work that we're doing. And that gets us further away, so that's not right. Give me 1 second, and I'm going to step away for a second.
so here we are, mere registers away. Mere registers away from having this solved. And this is actually on some much larger functions where things are, and sometimes this can be quite the impasse. But we will not be deterred. So let's look at this again, make sure that we're jumping to the right place. So we're jumping down here to this random line. I don't see any obvious way to see any obvious way to set this without checking for whether it's null or not first. I also don't see a reason why we need to let's look at the definition of this create entity factory. Let's see if maybe there's something else that's going on here. Okay, I'm grasping at straws. Oops, don't want to fork that. I want to save it. I'm not sure why these vertices are wrong. So we have another tool. Move this back over. And that is the permuter. The permuter is like when you need a hammer, but all you have is a chainsaw. So we have our weapon 15 file that is compiling, but it's compiling to something incorrect. The permuter is going to go through, and it is going to tweak as much as it can and try to find some version of the code that works. So we tell the permuter where our C code is. We tell the permuter where the original assembly code is. And then we have it get going. And it knows that there's a difference of 50. And it looks like it might have found it. So let's see. So we look at it will output a diff. And so it wants this in a new variable. So we will give it one. We will call this hand. And now it matches. Oops. Of course, you didn't see any of that. So I'll go backwards. So we have our original code here. We're just doing this all inline. The code wants us to pull that out into a separate variable, or the permuter says we should, and we get a match. Things like that are frustrating to me. Is that how the original devs did it? I don't know. One thing we can try, I'll try this real fast, see if this will do the same thing. So we're going to say if the hand was 0, EF. I really don't like those unnecessary variables. That gives us the same thing. So that's most likely what it was, a permutation that I didn't try on my own, but should have, because that's fairly obvious. So we can get rid of that variable then, not necessary, and we've solved it. That's it. So now we have something. The only thing that isn't matching is these two sets of immediate values. We'll copy their function, go back to the file where this was, paste it in there, make, and now everything's okay. So we went from, to kind of backtrack, we went from having known assembly for a particular function in this weapon module. That looked like, try to get this all on screen in a nice way. And maybe readable. Hopefully I have a big screen. So we have this assembly. We used decomp.me to get a rough idea of
what that function looks like and the general logic laid out in that function, so that we don't have to decompile absolutely everything by hand. And then we go through and with some knowledge of the existing code base and patterns that have been used there, we go through and clean up that function so that it can compile back to the same binary or same assembly that we started with. In this case, 99% of the things that needed to be changed or tweaked are very common things that somebody familiar with this code base would be able to find. The one interesting or difficult area was how this particular control structure worked. I went with a ternary. It turned out that it was just a simple conditional statement with two branches. So that's it. Let's do one more thing, and then we'll send out up here. So we are first going to look, or the last thing we need to do is this draw mode down here is going to be one of the predefined draw modes, so we'll go find those draw modes. Value we're looking for is OX70, which is these three unknown values, which doesn't help us, but will be easy for somebody to search for in the future once those things are known. I like to do these backwards because that's the way my brain thinks. Factor out the biggest down to the smallest. Okay. Save that again, and we're going to take this and put it back here. We can get rid of this include line because no longer necessary. I was working in a branch for other work that I did, so now would be a good time to move this to a new branch. And we'll just call it this. So we know that this builds. We'll build it one more time for fun. There's symbols that I guess I probably need. So we're going to run make format. That will use Clang format to style the code in a way that's consistent with the project. Unfortunately, it takes away my preferred function calling convention, but that's okay. Actually, let's go back here fast. We're done with decomp.me. We don't need it anymore for this particular project. Because those immediates aren't matching, we won't get 100% match, which is frustrating. But we know that it does match, so we're going to click this match override and say that is correct. Okay, going back to the terminal, we're going to commit this particular chunk. We'll say that we're going to decompile.
then I push this to my personal repo. So there is the project repo. I don't have commit permission directly into that repo. So what I typically do then is go here, create a pull request from what was uploaded into, and then I do a small self-review just to see would I accept this if I was looking at it fresh. So the first, what I'm looking for is things like flags. Typically, if a thing is marked flags or mode, there's often macros for possible values for those. We can't use enums necessarily because enum size isn't defined, and there's no way to predefine an enum size in the version of GCC that we're using. So we largely rely on the integer size for the field, and then going back and using macros to build the values for that field. Unfortunately, we don't get some of the type safety then, but when you're dealing with nearly a 30-year-old compiler, that's what you get. Let's see. I don't believe that there is sometimes there's enums defined for entity IDs, so we can see if that exists. And there's not. And like I said, I guess that wasn't yeah, we don't really see some places it's defined, but it's not used. This is the first time it's been used in weapon. So there's nothing more to do there. And then looking through the rest of it, I see some personal style things that I probably would change that the linter didn't pick up. But other than that, it looks pretty good. So I'm going to set a note here. This nice small PR for somebody to look at. And it's sent. Now, when the PR is sent, a bunch of checks are going to be done to make sure that this code compiles correctly, that it's formatted correctly, and doesn't conflict with anything, so it can be merged cleanly. And assuming all those checks pass, one of the diligent reviewers will come through and they'll approve it and they'll merge it into the base. And then when we look at this progress in a couple hours after it's merged in, we should see that weapon is slightly higher than it was. So weapon currently is sitting at 94% complete, 94.7. This will probably bump it to maybe 94.75, 94.8. Small bits, but chipping away at it, and we'll get there slowly. All right, that's it. We got one done.
thanks for watching. Hope you enjoyed. I'll be back tomorrow.